Hi, welcome back. I'm Anna Delaney, and I'm delighted to introduce this next session, Exposed, Real Fraud Rings and How They Were Caught Red-Handed. In this session, Brian Pramov, Director, Customer Success at DataVisor, will dissect 3 real fraud rings to show the DNA of their newest attacks, super modern social engineering, device emulators, residential botnets, and more. Brian, it's all yours.
Thank you very much. Today, we're going to talk a little bit about real case fraud rings and how DataVisor was able to capture those and kind of give everyone a general idea of how we can better react to fraud rings and take a more proactive approach and how to stop those. So a little bit about myself. My name is Brian Pramov. I'm the Director of Customer Success at DataVisor. I have over 15 years of experience in the financial and e-commerce industries to better help detect fraud from, again, that proactive and reactive response. So I've worked in the money transfer as well as the financial industries. And now currently I'm helping those types of clients to help better detect these fraud rings and to help them save some more money. And I'm currently based in Denver, Colorado. So on today's agenda, we're going to talk a little bit about the sophistication that fraud rings are bringing to the table these days. So, you know, back about even 10 years ago, they didn't really have to do much because there wasn't a lot to be able to help these victims better detect that fraud. So what does that mean for clients today and how we can better detect that from a much quicker response time, as well as the fraudsters are now organized. What that means is it's a lot cheaper for fraudsters to work together and buy stuff off of the dark web, and how we can better basically detect that from a quicker response time. And now the crime ring example. So we're going to show 3 different examples from 3 different types of industries and how our team was able to better detect that. And we're going to showcase a little bit of the visualizations around that and how you can basically use those pieces to better detect that fraud. And then lastly, we'll talk a little bit about the 3 takeaways that we think everyone should take from this webinar and better help their teams to detect fraud. So the first piece we want to talk about is the sophistication of these fraud rings. So I don't know about anyone else, but you know, fraud doesn't exactly work from a 9 to 5 kind of schedule. Usually it's a little bit more of an inopportune time. So that's why we put it as it's 2 a.m. on a Tuesday, you know, or Friday at 9 p.m. It's never going to be the most ideal time for anyone to help detect these fraud rings. And if you look at this data from this data set, you'll notice that there's a couple of key takeaways, like the email addresses are starting to follow a same pattern, or the devices. We're seeing a couple of the same device type pieces. One of the things that I've seen in the past with something like this is a lot of them will use something as simple as like the same screen size on their computers, or they might use the same type of language, browser language, that's different than where they're basically based at right now. So it's little things like that that you sometimes, when you're looking at a big data set, might not be able to identify. And so when these transactions come in, you might not be able to immediately detect that fraud ring. The problem with that is, if you think about this next time and all of a sudden next week, that fraud ring comes back and they've started to throw out a new kind of pattern, but it's not necessarily that different. So if you look at right here, this email address, it's still following the same email pattern, except for the fact that now they've changed it just ever so slightly and still using the same IP org. So you have a lot of these kind of problems where they've hit you once, you found a way to basically react to it, but they've found another way to basically wiggle their way through and beat you again. And we put this kind of graphic on the left-hand side because if you look at this week 1 and week 2 and you're constantly losing money, it doesn't exactly look good from an fraud operations team if, you know, your manager's coming back and saying, why do they keep getting through? And so we wanted to kind of show that in the fact that Bob's team is stopping fraud from a reactive state, but every week it's the same pattern and they're finding ways to stop it again. But at that point, you've already lost. Like, there's no way that people are going to be able to stop it at that point. And so you have to find new and more creative ways to beat the sophistication of these fraud rings. And again, we're using a fairly simple example here, but they're finding ways to get through. And that's where you have to be a little bit more ahead of the curve on the fraudsters. So talking a little bit about the hard truth of the fraudsters and sophisticated criminals, the big thing is these fraudsters, if you look at some of these things, again, they're focused, they're organized, they're well-funded. The big thing is around that is when you talk about well-funded and organized crimes, they're not necessarily going to be taking just 1 or 2 social security numbers or credit card numbers at a time. Really what you're going to find is people going on the dark web, they're going to buy a bulk amount of that personal information, and then they're going to find a way to get it through on multiple sites, and they're just going to find out what works. Like if they hit one money transfer company or one financial organization with that credit card, it might get through, it might not. Then they're going to still use the same one until the victim finds out that they're being victimized, and they're going to find a way to kind of get out there. So this is why we have the graphic on the bottom. The current amount to buy, a social security card is the same price as a cup of coffee. But if you think about that if they're going into a loan application company, let's say, and they took your social security number and your personal information, they could probably apply for a microloan as little as $800 or $1,000 and get automatically approved for those smaller loan amounts, steal that money, and then buy a PlayStation or maybe a washer or dryer and then sell it, and it's immediate funds for them. So the cost of $4 for them, they immediately get that return. It's roughly a 20,000% return on investment, and that's just one card or social security number. So if you compound that by a bulk amount when they buy it in bulk for 100 or 1,000 of those, you can see how it's very lucrative for the fraudsters to be able to do this from an organized crime kind of perspective. The problem for the fraud prevention team at that point is, how do you stop this so that all these victims don't get, stolen that money from a loan application perspective or from a financial perspective? Because not only are you losing money and you're on the hook from a fraud prevention team, it's also a terrible perspective and view on the company that you're working for, and it might take a hit from that company perspective. So we showed this icon because, again, if you think about that 100 social security numbers and they're just throwing it at the wall to see what sticks, you might detect 70, 80, and that's kind of the whole idea of the tip of the iceberg perspective. There might be some that are still getting through that you don't even know about, and that compounds from an organized crime perspective, where you're going to lose all of that money because you caught 70 or 80%, which is great, but not necessarily when it comes to fraud prevention, because I don't know about everyone else, but we have a very low threshold as far as what we're allowed to let through, something around the lines of less than 1%. So if you're missing a majority of that iceberg that you're not even noticing is getting through, that's when you have upper management coming back and wondering why this is happening. So that's kind of what we want to talk about, that this is just kind of the tip of the iceberg that you are viewing from a reactive state. So let's talk a little bit about these fraud rings, that we have a real use case and how we were able to detect that and show, a better way to detect that fraud and a better way to identify these rings that can be used across multiple platforms. So the first one is going to be a buy now, pay later loan. So if you remember a couple of slides ago, I talked about a $4 social security number. If you basically apply for a microloan, the chances of auto approval, if they have all your personal information, is very, very quick. So if they do something or $1,000 or less, it's a great customer experience. That's going to make the company look very, very good when they have all of these loans coming through. But from a victim and a fraud prevention perspective, it's very, very difficult to be able to do these microloans, get them auto approved, and then how do you stop the fraudsters? So if you look at those attack techniques at the bottom, that's really what's happening. And that's one of the ways that we can kind of stop that is they're going to do those small loans to get approved. They're going to do it all from a small area. So if you think of those social security numbers, normally it's going to be from one device. So that's an easy way to kind of detect some of these patterns. And then it's going to be a high velocity. So one of the things that we've noticed when they're filling out that PII and registration information is sometimes you'll be able to identify the time that they register is much quicker than a human should be able to do it. And that's just again, this is where the sophistication comes into play, because once you stop that and you've identified that it's a bot creating all of these loan applications, they'll start to create these coding systems to basically make it so that it does mimic a human type of registration. So at that point, how do you identify these kinds of fraud techniques? And the best way we've found to do that is to use a consortium of data to help identify. So again, you have, if they've switched from the timing of the loans to be much longer, you still the IP around the device or something along those lines, or dollar amounts like we saw in those tables, where as much as they're trying to differentiate it to look different, it's still going to identify key pieces that the fraud team can be able to better identify. So how do we do that? Well, we've shown a loan, let's say, and this is a true fraud scam that we were able to identify around these loans. So using our application to kind of show linking, we can see that this initial customer is linked by multiple information. So if we see the IP address has over 99 different links, we have the username of Arya Stark has over 75 different links, but more importantly, you know, we have things like the address and the device that are also linked. So when we expand on those types of links, we'll see that all of a sudden we're starting to see a lot more loans with probably all these microloans that they're going to try and get approved very quickly so that they can take that money out and steal it from you. So one way we've been able to better identify this is if you have one or two loans that you've already identified to be fraud, you can now show this linking that these are all connected and all to be bad. So it helps give the fraud team more power and more visibility into how big these fraud rings are able to be identified and to be able to stop them in a much quicker way. The next fraud ring that we want to talk about is related to the cryptocurrency. So cryptocurrency is exploding right now. And with that, it has a double-edged sword. There's a lot of pros, there's a lot of cons. A lot of people can make a lot of money, and that means that there's both good and bad people making money. So the way that these cryptocurrency platforms are working is they have to work almost overtime to be able to stop a lot of these new clients and new customers trying to send money or steal someone's digital wallet with their cryptocurrency. And the example we're going to show, you can see down below, had over 40,000 users involved. And that's just the users. That's not even the transactions. And it's a much more sophisticated platform and a much more sophisticated fraud ring when they had to stop this type of cryptocurrency fraud, because there's not necessarily a lot of regulation in that, but you don't want the cryptocurrency company to be looked at where this is where a lot of fraud comes from, or, you know, this is where a lot of people lose money. So that's where we come in to basically help them identify these things from a much more proactive perspective. And so let me just show you kind of one of the ways we were able to identify this fraud ring. So this is an example of how we've used our unsupervised machine learning models. And this is kind of showing the clusters around that exact fraud ring. And this is, again, just a subset. If you think 40,000 users, can't exactly show it on a slide very well. So the way we did it here is to kind of identify and highlight a lot of these pieces. So if you remember, I brought up as an example that people were using the same phone screen size. This is kind of the same thing. So they're using a lot of the same type of internet and computer-based applications. And so that's just the beginning of us to be able to help identify this from a cluster. Then you can see we have a lot of these users using the same IP, and then it just connects them more and more and more, as well as they're following the same email address kind of pattern. And again, this is just the tip of the iceberg when it comes to a UML type cluster. And that's where you start to see that bottom of the iceberg to make sure that you identify this entire cluster, because you don't want to miss a lot of these. When you think about 40,000 users, if you let just 1,000 or 2,000 in, it's going to be a big problem. They can still steal hundreds of thousands of dollars. So that's where this UML comes in as a really big benefit to our clients, in the sense that they're able to better detect fraud at a registration. If you notice, this is the sign up piece. So we're able to identify it at a registration so that we stop them before the transaction even happens. And that's huge in the sense that you don't necessarily want your card to be compromised, but if you can stop it at the registration, all the better for you. And it makes the fraud team look like they're geniuses, which is all great. And we want to make everyone look good like that. The last fraud ring I want to speak about a little bit today is more around the lines of, we showed kind of the linking, and then we showed a little bit of the UML piece. But how do you play it all together? The thing is, you don't want to be a one-trick pony. You want to be able to identify these things all together. And so you want to have a multi-tool kind of platform to better identify these fraud rings. And that's kind of what we wanted to do with this, is to showcase from a online lending financial company how they were able to identify and use both of the tools to identify these types of fraud rings. So if you notice here, we've got both the UML down at the bottom and the left, and we've also got the linking on the right. The big pieces that I want to showcase around this is, again, it's using the tools together. You don't want to use just one or the other because you still might miss things. So if you look at the linking here, you'll see that we have these two clients are linked together right here, but then we also have this grouping over here, and then we've got a little guy down here, and then the 5 or 6 down here, but they're not necessarily all linked. So how did we identify this? Well, the linking, you don't want to kind of over analyze all of the fields. So if you have thousands and thousands of data fields and data elements, you don't want to add them all to this linking, because then you might just see a blank screen with all of the different lines. So you only use the very strong attributes to connect via linking to be able to show from a visualization standpoint how these people might be connected. When you look at the UML perspective of it, it'll be able to identify all of those thousands of different fields and attributes around these people and be able to tell you, so if you look at this, how these clusters are connected. So for instance, this one, the big one is they're all using the same shared IP from the same data center. So while these ones are not necessarily using the exact same IP address, they're all linked by these types of pieces. And that's where it's really important to be able to show that kind of view to your fraud operations team so that they can identify that not only are these 4 people bad from this UML cluster, then you also have the linking that you can say, all right, these other people are probably related to the same fraud ring, so let's stop them before they can transact. That's what we really wanted to showcase here, where all of these people might be bad. And I do love that we've made it so that Sansa Stark, is assigned to these to make sure that she identifies all of these people as bad. Lastly, I want to talk a little bit about the main takeaways, but I'm going to take a sip of coffee first. So the main takeaways I want to talk a little bit more about, because not only are these very, very important, but I want to talk a little bit about personal experience around some of these things that I've seen in the fraud industry over time and how we've been able to identify those in my previous life. So first piece, closely mimicking good users' behavior. So if you remember that first fraud ring or the first example, we wanted to be able to stop them if they're doing a registration and they've hit it with a bot, in the sense that they've got that advanced scripting and they are registering within a minute. And then all of a sudden they're changing that scripting to more mimic a human's kind of registration process. How are you going to better identify that? Well, by linking and by using models to be able to identify those clusters that, again, from a human's eye point, if you have over 1,000 different data fields, it is not very easy to identify these types of combinations. So that's how you're going to be able to identify some of that more advanced scripting pieces to look for the ones that are trying to be good, but are still very much part of an organized fraud ring. The other one is long incubation time for synthetic ID. So this one is more along the lines of, we've seen client or victims where a fraudster will go in, register, wait 2 weeks to a month or to 2 months so that it makes them look even more like a good user. They haven't done any transactions, but basically what they're trying to do is establish a good type of existing user level. And then as soon as they hit a certain time period, they're going to hit you with that kind of bot type transactions or loans, so that they're going to auto approve those types of transactions in a much quicker way. The way that you better kind of identify those is, if I see a client doing very little activity, and you can use velocity features or something along those lines to better identify this, that if their average transaction is $0 and all of a sudden they go to 50 transactions in a week, that's one way that you're going to be able to identify a velocity feature, a reactive state, because you can build rules around that. You could add it to your models to be able to identify from a quicker standpoint that all of a sudden this person's starting to rapid fire on you, that you might be able to identify that and do a manual review and block that type of client. The next piece is heavy investment in digital technology. Bots and emulators. So the big thing with that is, I've seen fraud patterns where they will hit you with 1,000 transactions within 30 seconds. And the hard part for the fraud operations team is, you still might decline 950 of those, but if 50 of them get through, you're at a loss. So how do you find a way to identify that? Well, the big piece is, you've got to, again, take it from a proactive and reactive state. The proactive is using those models and fine tuning those models so that if you get hit with something like this, you can fine tune that model so that it's not going to happen. They might get, at that point, reduce it down to 5 transactions instead of 50. And then you're looking like a rock star to your leadership, that there was 1,000 transactions came in, only 5 actually got approved, and we were able to stop the other 995. The other one is emulators. So, if they're throwing from different locations and they're being able to throw all this data at you at once, how are you going to be able to stop that? Well, you have to stay up with the times. Again, you want to take that multi-step approach. You don't necessarily want to be that one type of way to stop fraud, because they're just going to keep coming at you. They know how to beat you. And so if they keep buying cards, you might decline those cards. They'll come back the next week and they'll come in with a new set and you're in trouble. So you've got to be able to find a way to take that proactive approach and then supplement it with rules if things trickle through. And then lastly, the high degree of criminal collaboration. So this is a very fun one, in the sense that we have fraud as a service and fraud universities. If you look on the dark web, there's actually fraud universities that'll teach you how to basically do fraud from a very cheap perspective. And it's teaching more and more people how to beat your system. If they also, the fraud university, let's say there's a financial victim or financial industry that has become victim, and you have stolen ACH accounts and they found a way to beat your process. Well, they can now go on the dark web and tell everyone how to beat that process. And so not only are you in trouble from the one fraud victim, now you have all these other fraudsters that know how to beat your system, and you're going to get hit pretty hard and pretty quick. The other one is the fraud as a service. So in my previous career, we were able to identify that in a money transfer, they were sending money to these different locations, and people will basically sell their service to go pick up the money for a small fee, and then basically take all that fraudulent money and then send it somewhere else. So the example is basically where, if I'm using my computer to send 100 transactions to Europe, I have someone that has basically used their fraud as a service to go pick up that money in Europe as cash and then deposit it into a separate account for me, so that there's no way for me as the money transfer service now to recover those funds. And it's very difficult at that point to identify how you stop it. And really, the big piece is you need to be able to look at it from both a sender and receiver perspective. If you can gather that receiver information, it really helps, so that if I'm sending from multiple people, let's say mules, that are sending to one location, you can start identifying that, all right, why are all these people sending to one person all of a sudden at once? And then the vice versa. You might have one person on a computer sending to multiple locations, where you have to identify that there's all these, or one device sending all these different people's information, all these different transactions into, let's say, 5 or 6 locations where they go pick up the money. The hard part is you go and you react, you've lost the money, then you have to stop it. But how do you stop it if they move? Like, for instance, if I'm in England and I'm the mule and I'm picking up the money and you block everything going to this kind of general geolocation, but then I move over to Ireland, then I move to Scotland. How are you going to stop that? You can't exactly shut down the entire country. So the way you do that is you use things like UML, you use things like this linking, so you can identify that pattern to better identify it and better stop it so that you don't have to shut down these geolocations. And that's pretty much all I had. I wanted to thank everyone for basically listening in on me. Again, I'm Brian Premov. I work at DataVisor. We are a fraud detection tool, and my job, again, as Director of Customer Success, is to basically make everyone else look good. So if you're a client or if you're an interested client, I'd love to talk to you, and thank you very much.
That was a brilliant presentation, Brian. Thank you very much. And thank you, our audience, for joining us and for your questions. Do enjoy the rest of the program.